Hello, my name is Victor Hengjun Hang. My matrix number is 25004013/1. My program is that of the Bachelor of Biomedical Engineering. And in this video, for the video assignment of circuit theory, code KIB1012, in this video, I shall present the application of a first-order design circuit in a biomedical engineering device. Before going into the main point, I would like to give a brief run-through of the medical device of my choice in this presentation. In this case, it would be the pacemaker. Pacemakers are a device that generates impulse to regulate heartbeat to maintain a steady rhythm of the heart. It uses RC circuits in many of its components and parts, but the main part of this presentation is about the pacemaker's timing circuit. In this presentation, I'll explain the basics of a timing circuit in a pacemaker as well as its output. The main function of a timing circuit of a pacemaker is heart rate control. It can charges and discharges to create a pulse that can consistently simulate the rhythm of the heartbeat, as well as to control the interval between said heartbeat. The simplified version of the timing circuit of a pacemaker can be shown in this circuit diagram to my right here. It is a basic RC circuit with a voltage source, a resistor, and a capacitor. The value in the diagram, or the lack thereof, is just an example. The above equation here shows the voltage of the capacitor when it's charging and discharging respectively. When the current is running through the circuit, the capacitor will start to charge towards the Vs, that is the voltage supply through the circuits, until it reaches a threshold. Then it will cut off and rapidly discharges. The rest of the circuit acts as an open circuit while the capacitor is charging. It then will short the circuit when the capacitor discharges, resulting in the V being cut off and the current running through the circuits. This is the mathematical way to calculate the desired heart rate, derived from the equation of the charging of the capacitor. Vt equals to Vs times 1 minus e power of minus t divided by Rc. Replacing Vt with V cutoff, you got V cutoff equals to the same equation. After rearranging the equation and substituting the heart rate h and making R the subject of the equation, we can use the below equation to calculate the exact resistance needed to achieve the desired heart rate. The equation R equals to minus 60 divided by H times C times 1 minus V cutoff divided by Vs. If the value needed to find is the capacitance, simply make it the subject of the equation and basically just exchange place with the R. The graph on the right here visualizes the output of the timing circuit. As you can see, it is a sawtooth signal that should be the ideal output of the pacemaker. The time it took while discharging is almost instantaneous. After discharging, the capacitor would start charging again. This repeating signal is the rhythm created to simulate the heartbeat. With each discharging of the capacitor, sends electrical signal through the heart, just like what an organic pacemaker cell would do. Depending on the capacitance or the resistance of the timing circuit, the frequency of the output signal will also change, resulting in the change in the beats per minute of the heart. And that is the end of my presentation. Thank you for listening. The next slide will have some references about the material I referenced while making this presentation. Thank you.